Alright, welcome to the first Algebra 1 lesson. This is lesson 1.1. Today we're going to look at powers and roots. You can see on your screen that the learning target is that you will be able to simplify expressions that involve exponents and square roots. So for most of you, this is review. So I'm going to treat it that way. Now when you're in a math class and you're watching a video, really the best way to learn is to watch it and write some things down as you go. But you can see you're in play pause it for this one. So I will stop the video at certain points and ask you to respond. For now, just watch and get as much as you can. So we're going to start with the definition of what a power is. A power is a number that's written with a base and an exponent. So this number is the base, and this number up here is the exponent. And you might already know that when you have a power, you take the base and you multiply it by itself the number of times that's written in the exponent. 2 times 2 times 2. There's 3 of them. So 2 raised to the third power is equal to 2 times 2 times 2. And what this demonstrates is 2 different ways to write an exponential number. That's this part down here. The first way is when you have an exponent, that's called exponential form. 2 to the third power has an exponent, it's exponential. When you write out what that means, like 2 times 2 times 2, that's called expanded form. So 2 times 2 times 2 is the expanded form of 2 to the third power. Pretty simple. Now if you wanted to figure out what the answer to 2 to the third power, or 2 times 2 times 2, you would be simplifying. So this is just a quick definition of what simplify means, and that just means to make simple, or make it as simple as possible. And the only reason I'm giving you that definition is sometimes people want to use the word solve, like you're solving this. And the word solve is reserved for equations. This is an expression. So here's a couple examples. In this table there is an exponential form, an expanded form, and the simplified form. So 10 to the 7th power is an exponential number. To write that in expanded form just means 10 times 10 times 10. How many 10s do I have to write out? 7. 10, that's 4, 5, 6, 7. 10 times 10 times 10 times 10 times 10 times 10 times 10 is 10 to the 7th written in expanded form. To simplify that, that means I'm going to figure out what that equals. Now there's a trick with tens. Whenever you multiply 10 by itself some number of times, the answer will always just be a 1 followed by the number of zeros given in the exponent. So this is 1 followed by 1, 2, 3, 4, 5, 6, 7 zeros. So 10 to the 7th turns out to be 10 million. In the next row, 0.2 times 0.2 times 0.2 times 0.2 times 0.2. How many 0.2s are there? 1, 2, 3, 4, 5. So to write that in exponential form, it would be 0.2 raised to the 5th. Now, whenever you raise a decimal number to a power, it's not wrong if you leave it like this, but it's clearer or easier to read if you put that in parentheses like I just did. And it turns out that 0.2 to the 5th power is equal to 0.00032. Now, can you do that in your head? Maybe, but if you can't, grab a calculator and multiply 0.2 times 0.2 times 0.2 times 0.2 times 0.2. Or if you know how to use the exponential function on your calculator, do it this way. The last one, 1/2 raised to the third power, means 1/2 times 1/2 times 1/2. Now notice that the fraction is also written in parentheses like we did with the decimal, and that's just to make it easier to read. This is the expanded form, simplified. You multiply that out, you get 1/8. Okay, now it's your turn. try to fill in each of these boxes to write out the expanded form, the simplified form, and the exponential form. Alright, here are the answers to that. Those should have already popped up when you answered. Okay, now the next definition we're going to look at is called a radical. And you've probably seen this before, you probably call it a square root. The symbol itself is actually called a radical. The number inside the radical is called a radicand. And you've probably seen it like this, square root of 4. Or you could say this is the radical of 4. For now, we're going to leave it as a square root. Square root really is asking you what number times itself is equal to 4. And the number that multiplied by itself that equals 4 is 2. So your answer to the square root of 4 isn't 2 times 2, it isn't 4, it isn't 2 squared, it's just 2. So if you look at these examples below, the square root of 81, the number that multiplied by itself that gives you 81 is 9, so the square root of 81 is 9. If you have a square root of a fraction, like 9/16, then really all you have to do is ask yourself, what's the square root of 9? That's 3. And what's the square root of 16? That's 4. So the answer is just 3/4. When you take the square root of a decimal number, it's a little bit tricky. If you just look at the numbers and ignore the zeros for a second, the square root of 64 is 8. Then you can count up the zeros. As long as the number of zeros is even, you just take half of them, and that gives you your answer, 0.008. Now, I'm trying to give you the simplest way to look at these for now until we get into a little bit more detail later. So, give these next 3 a try and answer them. Alright, the square root of 25, hopefully you got 5. The square root of 1/36, 1/6. And the square root of 1.21 is 1.1. Right, the last thing we're going to look at are called perfect squares. A perfect square is what you get when you multiply a whole number, like 1 by itself, or square it. 1 squared is 1. Or 2. 2 squared is 4. As long as the number that you're squaring is a whole number or an integer, the answer that you get is called a perfect square. So it's going to be a good idea that you memorize the first 15 perfect squares, as you can see listed here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25. Now, I'm writing these out because I have them memorized. I can also do the math in my head. 6 times 6 is 36. 7 times 7 is 49. 64, 81, 100, 121. Now, as you get up into these higher numbers, it gets a little more difficult, but I have them memorized. 12 squared is 144. 13 squared is 169. And then I always know that 14 squared, I just take the last 2 digits and reverse them. 196. And 15 squared is 225. Those numbers that I've just written in red are all perfect squares. And the thing with perfect squares is, when I take the square root of them, like say 100, the answer is always a whole number. Square root of 100 is 10. Square root of 196 is 14. Alright, that's it. That's it for the first lesson. Now you should move on and do the assignment that's associated with this first lesson. Good luck.